Okay, on this question, they're giving us a triangle and they're saying little a is 7, little c is 9. Find all the trig functions for angle A. Okay. Little a is 7, so I'm going to put right here 7 by the little a. Little c is 9. I'll put a 9 right there by the little c. So the first thing, so step 1 is to find the third side, little b. This side down here. We got the 7 and the 9. Let's find the other side. How are we going to do that? Well, you probably remember the Pythagorean theorem. A squared plus b squared is c squared, right? That's true for any right triangle. So it's not all triangles, but it's any right triangle. Any right triangle. Okay, and this triangle has a right angle right there. So it's a right triangle. A squared plus b squared is c squared. C squared is the hypotenuse. It's the longest side. The other two are smaller, so they squared add up to be the biggest side. So, okay. So what is the little a? It is 7. So 7 squared. Little b, we don't know. Little c is 9. So work that out. Use your calculator. You need to. 81, subtract the 49 from both sides here. Boom. So b squared is where I might need a calculator. Is that 50, 31, 32, I think. 32, we get to there. And so now we're going to have to hit the square root button on our calculator to finish it up, right? Square root, square root. So little b is the square root of 32. I'm just going to leave it square root of 32 for now. I'll get decimals later. I know they want decimals. We'll get there. So we'll leave it for now. So b is the square root of 32. It's just easier than writing a bunch of decimals. I'll hit the buttons on the calculator in a minute. Okay, so now we've got all three sides. That's step 1. So now let's go to step number 2. We're going to find all the trig functions. How are we going to do it? SOHCAHTOA. So SOHCAHTOA is our memory device to help us remember how they go. So and that's all somewhere in the notes on the notebook, I'm sure. Let me maybe it's worth it. Let me go there real quick. Probably using up too much time. Try fast. See. So chapter 7. There it is. Okay. So terminal sector. There it is. Okay, definitions of the trig functions. There it is. So right there in the notes. Let me move that up for you. Okay, so yeah, so right here in the notes. This is the note in the notebook. This in for you, where I can write on it. Okay, there we go. All right, so this is in the notes that I provide for you in the notebook. And it tells us that there's SOHCAHTOA. And what does that mean? Sine is OH, opposite over hypotenuse. Cosine is AH, adjacent over hypotenuse. You can use these notes on the exam. Tangent is OA, opposite over adjacent. And then these guys are just the upside down, upside down, upside down. Notice opposite over hypotenuse, then flip it. Hypotenuse over opposite. Adjacent over hypotenuse, flip it. Opposite over adjacent, flip it. So those are just the upside down. Now, and here I'm drawing you some, I copied off the internet, some triangles, and I'm showing what we mean by opposite, adjacent, hypotenuse, right? So it all depends on where the angle is. So if your angle is right over here, then the side opposite that angle is over here. That's the opposite side. This one's always the hypotenuse. See how the hypotenuse is always, because that's the longest side. That's the one across from the right angle. Across from the right angle. It's the longest side. So then if the angle they're wanting you to focus, they could ask you about this angle up here, or they could ask you about this angle down here on various problems. If they ask about this angle, then this side is opposite and this side is adjacent. Adjacent just means next to the angle. And this is always hypotenuse because it's across from the right angle. Whereas if you're starting with an angle up here and they're saying, hey, take this angle up here and find the sine and all the other stuff. Well, from this angle right there is opposite, isn't it, of this angle. So if this is the angle you're talking about, then this side down on the bottom is opposite, and this side is next to it, adjacent. Adjacent means like your neighbor lives next to you. So whereas if this is the angle they want us to find everything for, then the opposite is over here. So let's go back to our problem. What do we have? Well, we have this angle. See, they're saying angle A, angle A, angle A, which is right here, angle A. So then this side over here is opposite. Now, this is the hypotenuse always because that's across from the right angle. It's the longest. So then what's left, this side must be adjacent. See how I determine that? Now, if we were talking about angle B up here, if they were saying find the sine of angle B and the cosine of angle B and the tangent of angle B, etc., then I'd be up here at angle B, and the opposite of B, the opposite of angle B would be the bottom. This would then be opposite. And this would be adjacent. This is next to B. And this is still hypotenuse. That never changes. That's across from the right angle. Is that making sense? That's the key. You got to focus on what do they want? They want the sine of angle A. Where is angle A? Right here. So what's the opposite of that? This side. It's hypotenuse, and that leaves this as adjacent. Okay. So sine, SOHCAHTOA, opposite over, as it says right here, opposite over hypotenuse. So opposite, that's 7 over hypotenuse, 9. 7 over 9, opposite over hypotenuse. Next, cosine. Cosine is adjacent over hypotenuse, adjacent over hypotenuse. So that's, and I'm going to make these decimals in a minute. Let me first just write them down. Square root of 32 over 9. Right? See what I just did there? I just did adjacent over hypotenuse. Now, tangent is opposite over adjacent. So I'm going to grab, what is it? Opposite over adjacent, 7 over the square root of 32. And again, I'm going to make decimals in a minute with my calculator. Let's finish up first. Now, secant, what is that? And cosecant and cotan. Well, if you go down to the notes again, which you can totally use on the exam, it'll tell you. Cosecant is opposite of sine. Let's go do that one first. So you take the answer we got from sine and jump down here to cosecant and just flip it, 9 over 7. And then cosine, flip it, you get secant, 9 over the square root of 32. And then cotan, that's opposite of tan. No big surprise there. Like that. So I just flipped the fractions upside down, just going by the definitions again right here. It says sine, opposite over hypotenuse, then flip it for cosecant upside down, and cosine, flip it for secant. So I just flipped them. So sine, 7 over 9, flip it, cosecant, 9 over 7, etc. Now let's just hit the buttons on your calculator. I'm just going to divide 7 by 9 because they want decimals on these. So I'm getting 0.777 forever, which rounds to be 0.8 because they said 1 decimal place. And the next one, square root of 32 divided by 9 on my calculator, I'm getting 0.62 blah, 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 blah. So that rounds to 0.61 decimal. Next one, tangent, 7 divided by the square root of 32. I'm getting 1.237, blah, blah, blah. Round that to 1.2, 1 decimal place. Right, you remember rounding. Let me show it's clear. Well, I'm going to stop right here. Here's the bar. So if it's 5, the one that comes after is 5 or more, you round up, right? And now I'm down on the secant, 9 divided by the square root of 32. I'm getting 1.59, blah, blah, blah. That rounds to 1.6. And then cosecant, 9 over 7, 1.28, blah, 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 rounds to 1.3. And last, got the cotan. I'm getting 0.808 on the calculator, which just rounds to 0.8. And so there we go.